Now we discuss next question. What is the dot product or scalar product of two vectors and discuss their properties? The answer is scalar product or dot product of two vector is defined as the product of the magnitude of the given two vectors with the cosine of the smaller angle between them, that is a vector dot b vector is equal to ab cos theta. If we have two vectors a vectors and second is b vector lies at an angle theta, then we find their dot product or scalar product, that is a vector dot b vector is equal to ab cos theta. And next is their properties. First property is dot product of two vectors obey commutative law, that is a vector dot b vector is equal to b vector dot a vector. Next property, dot product of a vector with itself is a scalar. What will be the square of the magnitude of the given vector? That is a vector dot a vector is equal to a into a cos 0 degree, that is equal to a square into 1, that is equal to a square. ਡਾਟ ਪ੍ਰੋਡਕਟ ਆਫ ਅ ਵੈਕਟਰ ਵਿਦ ਇਟਸੈਲਫ, ਯਾਨੀ ਕਿ ਅਸੀਂ ਇੱਕ ਵੈਕਟਰ ਨੂੰ ਉਸੇ ਵੈਕਟਰ ਦੇ ਨਾਲ ਜਿਹੜਾ ਉਹਦਾ ਡਾਟ ਪ੍ਰੋਡਕਟ ਕਰ ਰਹੇ ਹਾਂ, ਏ ਵੈਕਟਰ ਡਾਟ ਏ ਵੈਕਟਰ, ਦੈਟ ਇਜ਼ ਇਕੁਅਲ ਟੂ ਏ ਇੰਟੂ ਏ cos 0 degree. Then we get a square into 1. 1 comes from cos 0 degree is equal to 1, that is equal to a square. Next property, dot product of two mutually perpendicular vectors is 0, that is a vector dot b vector is equal to ab cos 90 degree, that is equal to ab into 0. 0 comes from cos 90 degree is equal to 0, then ab into 0, that is equal to 0. Next property is dot product of two collinear vectors is numerically equal to the product of their magnitudes, that is a vector dot b vector is equal to ab cos 0 degree, that is equal to ab into 1, that is equal to ab. And this is the fourth property of the dot product. And the next property, dot product of two vectors obey distributive law, that is a vector dot in bracket b vector plus c vector vector closed is equal to a vector dot b vector, a vector dot b vector plus a vector dot c vector, that is a vector dot c vector. Next property, dot product of two vectors is negative when angle between them is greater than 90 degree, that is a vector dot b vector is equal to negative if the angle between them is greater than 90 degree. Next property, dot product of unit vectors, that is I cap dot I cap is equal to j cap dot j cap is equal to k cap dot k cap is equal to 1, and I cap dot j cap is equal to j cap dot I cap is equal to k cap dot I cap is equal to 0. Next property, if we have a vector is equal to this one, that is a vector is equal to ax I cap, this is ax is the magnitude along x-axis, plus ay into j cap, ay is the magnitude along y-axis, plus az into k cap, az is the magnitude along z-axis. Similarly, we have next vector is b vector is equal to bx I cap plus by j cap plus bz k cap along x-axis, along y-axis, and along z-axis. Then we find their dot product is equal to this one. A vector dot b vector is equal to along x-axis ax into bx, ax into bx plus ay into by, ay into by plus az into bz, az into bz. And the next question is, what is the cross product or vector product of two vectors, and discuss their properties. Answer is, vector product or cross product of two vectors is defined as the product of the magnitude of two vectors with the sign of the smaller angle between them, and a unit vector which gives the direction of the cross product which is perpendicular to the plane containing that given two vectors, that is a vector cross cross b vector is equal to ab sin theta into n cap. If we have two vectors, this is a vector and second vector is equal to b vectors, lies at an angle theta, that is this one. Then we find their cross product or vector product, that is a vector cross b vector is equal to ab sin theta into n cap, where n cap क्या है, n cap is the unit vector, this is n cap is the unit vector. And their property, first property is cross product of two vectors does not obey commutative law, that is a vector cross b vector is not equal to b vector cross a vector. Cross product does not obey the commutative law. Commutative law ਜਿਹੜਾ cross product ਹੁੰਦਾ ਵਾ of two vector does not obey नहीं करता, that is a vector cross b vector is not equal to b vector cross a vector. Second property, cross product of a vector with itself is a zero vector or a null vector, that is a vector cross a vector is equal to a into sine 0 degree into n cap, that is sine 0 degree is equal to 0, that is a square into 0 into n cap is equal to 0 vector, that is equal to a square into 0. Next property, cross product of two mutually perpendicular vector is a maximum in magnitude, that is a vector cross b vector is equal to ab sin 90 degree into n cap is equal to ab into n cap, ab into 1 into n cap. 1 comes from sin 90 degree is equal to 1. Here sin 90 degree is equal to 1, then we get ab into 1 into n cap. Next property, fourth property, cross product of two collinear vectors or parallel vectors is zero vector, that is a vector cross b vector is equal to ab sin 0 degree into n cap, that is equal to ab into 0 into n cap, that is equal to 0 vector, that is 0 क्या है, 0 in magnitude. And the next property is cross product obey distributive law, that is a vector cross in bracket b vector plus c vector bracket closed is equal to a vector cross b vector plus a vector cross c vector. First we a vector cross b vector plus a vector cross c vector. And the next property is cross product of unit vectors, that is I cap cross I cap is equal to j cap cross j cap is equal to k cap cross k cap is equal to 0, and I cap cross j cap is equal to k cap, or j cap cross k cap is equal to I cap, and k cap cross I cap is equal to j cap. And the next, it is the inverse of this unit vectors, that is we have I cap cross j cap is equal to k cap, or this is j cap cross I cap, that is j cap is first and the second is I cap, that is j cap cross I cap, and that is equal to minus I k cap, that is equal to minus k cap. Here I cap cross j cap is equal to positive k cap. Here j cap cross I cap is equal to minus k cap. Similarly, in second, j cap cross k cap is equal to I cap, and in this k cap cross j cap is equal to minus I cap, and then similarly k cap cross I cap is equal to j cap, and in this I cap cross k cap is equal to minus j cap. And the next property, if we have two vectors, next property, if a vector is equal to ax I cap plus ay j cap plus az k cap, and b vector is equal to bx I cap plus by j cap plus bz k cap. Now, how to find their cross product, that is a vector cross b vectors? We find a vector cross a vector is equal to in this matrix form, that is first we write in matrix I cap j cap k cap, that is along x axis their unit vector is equal to I cap, along y axis their unit vector is equal to j cap, along x axis their unit vector is equal to k cap. Now the second row and the third row we write their magnitudes of the given vector, that is first we have a vector, then their magnitude is equal to ax ay az, and the second vector is equal to b vector, their magnitude is equal to bx by vz. Now how to solve this matrix? That is equal to, we find this matrix is equal to, now first we take along x-axis their magnitude is equal to I cap, that is equal to I cap. Now if we I cap, then this unit vector, that is we consider I cap, then we skip this column and we skip this row, and we have only these magnitude, that is ay az by bz. Then this is equal to I cap into ax by, that is equal to this one ay by, and second is az bz, that is equal to az bz in matrix form. Next, minus j cap, that is along y axis. Now we consider this j cap, then we skip these column and these rows, that is I cap and k cap, and this row we consider j cap, that is minus j cap. In matrix we have only these magnitudes ax bx and az bz, that is minus j cap into in matrix ax bx from this one ax bx and az bz from this one az bz plus k cap. Now we take along z axis their magnitude is equal to k cap, that is equal to this one. Now we skip this column and these rows, and we have only these magnitudes, that is ax bx or ay by, that is ay by into k cap in matrix. Now we solve these matrix, that is equal to I cap into AY VZ minus minus BY AZ minus J cap in bracket AX BZ minus AZ BX plus K cap into AX BY minus BXAY in bracket, and this is the answer of A vector cross B vector.